All right, we can kick it off. Thank you for joining today. We post these recordings on YouTube. My name is Mark. I am co-founder and CEO of Stemma, and today we have in Amundsen community two really amazing talks, and both the talks are from Lyft. And the first talk is from Allison, who has been working on a lot of updates to Amundsen search, and she'll show you what she's done and how the changes have impacted the experience of searching in Amundsen. And then the second talk is from Christian at Lyft as well. Amundsen used to have experience for displaying nested type, but it left a lot to be desired. And Christian has done a lot of amazing work in order for that desire to be lower and lower, and has improved the nested types quite significantly. And so she'll show you that. So without further ado, we can get rolling. And Allison, over to you.
Yeah, give me 1 second. I'm pulling up notes on my phone so I can see the presentation over here. Let's see. Okay, can everybody see my screen?
Mm-hmm.
Awesome. Sorry, I can't find my speaker notes. Should probably open this up earlier, but it's okay. Okay. Hi, everyone. My name is Allison Suarez, and I am in the Amundsen team at Lyft. And in the last, God knows how many months at this point, I've been making a lot of improvements to our search service because it was a big pain point that a lot of our users internally at Lyft would bring up over and over again, and we decided it was time to do something about it. So we have quite a few new features to go over, as well as how the search service was kind of redesigned and the search experience was improved in the front end as well. So I'm going to cover a little bit of what searching used to look like in Amundsen. So we separated search into V1, which is what we had before, and V2, which is the new version, just for simplicity's sake. So the V1 version of the search service had searching and document updating endpoints for each resource. So it was really hard to extend because every time you wanted to have a new resource added to Amundsen, you would have to then go ahead and create a new endpoint for it. Rather than just extending a single endpoint, which is what we do in Search V2 now. Also, we relied a lot on string templating to create a query that we would then send to our backend in Elasticsearch. Right now, and now we leverage Elasticsearch ESL, which is a wrapper for the Elasticsearch Python library that allows us to use Python objects for mappings and queries, which makes it just way more easy to write code for it and update the queries and do anything you need to do with Elasticsearch. We also used to use the function score in order to score documents when searching. And this is a misuse because function score is usually used for performing operations are really computationally complex, not necessarily for just scoring and ranking documents based on how much they match. That is better suited for other queries that I'm going to be discussing later on. Another issue we had was that we had very little ability to customize the search experience without having to completely basically overwrite the functionality of the service. So now we've introduced changes that allow us to customize at multiple points. We can customize our mappings for our indexes in Elasticsearch. We can customize the extraction query. So from extracting from your database, let's say in our case it's Neo4j, and writing into Elasticsearch. And we've made it so you can overwrite the search query per clause, because we're using a Boolean query. So you can just replace specific parts of the query to be able to get a better search experience that works for your particular use case if you want to. Oh, okay. So all that being said, what improvements have we made in Search v2 and what new features do we have? The first big area of improvement has been in search matching and scoring. So matching your query and scoring documents based on that query. And things that we've introduced to make these improvements have been fuzziness. So now you can have an inexact query and by query in this case, I'm referring to the user inputted string to search on Amundsen. So for instance, in the example in the photo, you can see that I've like written diver instead of driver, but the data sets match still return driver because Elasticsearch now has a fuzziness distance, which allows you to it gives you a little bit of wiggle room for typos and mistakes or just misspellings. And we have the distance right now automatically determined by Elasticsearch based on the length of that particular field, which is pretty cool. So we don't have to even worry about adjusting that. Another thing that significantly improved the search experience, specifically matching, is stemmings. So right now, in V2, we analyze text in a way that takes the root of the words or of the most important words in your documents. And it and by document, I mean like your tables or other resources, and it matches them to any other words that are similar in the root. So you can see the example here. You have consults is the root, and it reduces consultant, consulting, consultative to consult because that's the root of the word, and that way you'll make sure that all these words also match, which is pretty useful, especially if you're like looking for a particular concept, let's say within your organization. For instance, we use ride a lot at Lyft, and people will search things like rideable, rider, rides with an S, and all of these words will map to the same root. And another thing that we introduced that was pretty neat and really helped us improve the relevance of our search results is usage-based boosting. So any usage metrics that are indexed in Amundsen can be leveraged to provide higher search ranking scores to any resources by using the rank features functionality in Elasticsearch. So essentially, you'll provide it with a usage value for each, let's say, table you have in Amundsen, and that usage value is going to be used to score that table higher or lower on your search results. Other improvements we've made is adding multi-value filters. So right now, if you have a text filter, and this is mostly changed in the front end, you can see that if you type two words separated by a comma or two terms separated by a comma, you'll a and or switch will pop up, which can then allow you to join those things together in your search. So let's say I want to see tables that are under the schema and under the schema test, or under the schema test, it'll show me all results within those two schemas. And so we have multi-value and we have support for and or, which I already explained. You can switch back and forth in the columns where it makes sense. For instance, if you want a table that has both the columns ID with a wildcard match, so a column that ends in ID or the column DS, then you can select and it'll show you all the tables that have both. If you select or, it'll show you tables that have one or the other. Pretty simple. Another thing we added was default filters. So now you can configure a filter to be enabled by default whenever you search. So that filter will be on every time you search unless you toggle it off. And then in the vein of toggling, we added a, I would say fourth, maybe third filter type, which is a toggle switch, so that you can have like an on-off functionality to your filters rather than the checkbox and the text filters that we have currently. And another thing that we are currently working on, is still not out, so don't look for it. We'll make an announcement when it's fully done, is search highlighting. And this offers the option to basically show other relevant matching metadata whenever you perform a query in Amundsen. So let's say in this case, we're searching for ride. You'll see that we don't only get the matching table names, but we also would get matching descriptions, matching columns, and in the case of dashboards, we would see matching queries and matching chart names, I believe. So yeah, that's also something that we're pretty excited to roll out, something to look forward to as well. So how did we build all of this stuff? Sounds like a lot of things that kind of just happened magically. So the first important thing that we did was we added more robust text analysis and indexing time. So there's an example here where basically if you have some text in a certain field in, let's say, your table, like a description, and in this example, we have, this is the most interesting example ever. We now tokenize using a grammar-based tokenizer for things like descriptions, and then an alphanumeric tokenizer for things like columns. And this breaks your text down into tokens. And then each token goes through a variety of filters, which do a couple things. One, remove unnecessary tokens. So in this case, let's say this and is were removed. And then it also stems the rest of the tokens. So you can see that interesting was stemmed to interest. Example was stemmed to example without an E, etc. And we still and we also store other useful metadata about tokens before analysis to improve performance. So like, let's say this, after tokenizing, this example still keeps the start offset position, the end offset position, and the position in the original string. These are all things that just help improve performance and will help down the line for things like highlighting. So yeah, we indexed more robust metadata and analyzed metadata about each particular field to help out with our search. Another really cool feature that we introduced was using rank features, which is an Elasticsearch feature which helps you improve the relevance of your search results by boosting or deducting the score for a document depending on metrics like usage. In the case of Amundsen, we give a positive boost to documents with higher usage metrics, which we have a query by default on Neo4j. But you can introduce your own usage statistics or other metrics to significantly improve the relevance of your search results. And there's a link, I'm going to share this presentation after, on how you can do that. Basically, you can overwrite the query to introduce your own usage metrics and then add your own boost and all of that. And yeah, this is the default, saturation function is the default function that's used in rank features in Elasticsearch. The pivot is calculated by Elasticsearch, so it's not something you have to worry about unless you have a well-trained pivot. In that case, you can introduce it yourself. But we really encourage, if you have a set of numbers that you can introduce to your tables, dashboards, etc., to improve ranking, that you do use them, because it really, really helps improve the relevance of your search. And one of the most important things that we did was we changed the query type we use altogether. So in Elasticsearch, a Boolean query basically allows you to put together multiple clauses and multiple queries in a way that accounts for all these different scenarios that we run into. So for instance, you want to be able to match each particular field. You want to be able to um, add filters to your query. You want to be able to rank your query by usage. All of these cases can be accommodated by using a Boolean query, which basically aggregates all these different types of query and gives you a better result rather than having one type of query that accounts for all of your different use cases. So yeah, this Boolean query will provide you with a must clause, which matches at least one relevant field in your document or in your table, column, whatever. In this also allows us to use field by field matching by combining multiple match queries one after the other. And so each match query can be given its own boost and its own fuzziness. Then the should clause says, if you have a usage metric, please boost this particular document based on that metric. And we also not only use a Boolean query, but we use nesting of these queries to be able to perform things like and or for multi-valued filters in Amundsen. So you can see that example here on the purple, where or uses a filter, which then nests a Boolean query and uses should, whereas and is just the default functionality for the filter clause in a Boolean query. So we just use it as is. And then we also use wildcard queries to be able to support wildcard matching and filters, which is another function that we used to have and we still support. And then the last thing is related to the highlighting work that I was discussing earlier. We are supporting, we are able to do highlighting by using the highlighting API and Elasticsearch. This is basically out of the box, just works. You add a highlighting field to your query in Elasticsearch and it returns text that is highlighted with the matching portions of the text. It has tags around them, like HTML tags, so it's pretty easy to use. And yeah, that's basically it for what we use to build these new search features. So how do you get these features? Right now, if you update Amundsen Search and Amundsen Frontend, you're just gonna get out of the box the multi-valued filters and basically nothing else. It's just gonna be parity with the old V1 functionality, because in order to update to the newest functionality, you have to be on the newest Elasticsearch mappings. So for that, you have to update your Amundsen Data Builder version and then configure our new search metadata to Elasticsearch task and run that to map all your metadata in Elasticsearch for Amundsen. So you have to make sure to do that or you're not going to get most of the new functionality. And then, yeah, update your Amundsen Search to 4.0.2 and Amundsen Frontend to 4.1.2. And there's a whole tutorials document for how to do this that is linked in this slide. And you can also see these slides after the fact. I'm going to share them with Mark, and I think Mark can send an announcement about it. Yeah, that's basically it. Thank you very much.
That's great. Thank you, Allison. Any questions from y'all? I'll ask one. How did you track the improvements that it was having on the user experience? Do you have a particular metric you use to see like how search quality is improving? And do you have insights into how that has improved before and after the changes?
Yeah, so internally we keep a dashboard for all of our search changes, and the things that we track are things like, so we have the number of reformulations. So how many times in one search session, I think we use 30 seconds right now. How many times did someone retype their search query? And we can see like exactly how their queries have changed over time and how many times they have to repeat their query to get a result that they want. So that's one thing we track. Another thing we track is just the total number of searches that people are making. People, it seems in general, are using search more to get what they want rather than going directly to a link or something, or a bookmark or something they have. We have a couple of things. I'm blanking on a few of those right now. Oh, we have clicks on the top 3 tables so that we know what percentage of clicks are from the top 3 tables as opposed to other tables. And that has improved, I think, by like 5% since we introduced all the new search changes. So yeah, in general, we track a variety of metrics to make sure that we are in fact improving the search experience for our users. Yeah.
Other questions for Allison? All right. Thank you, Allison. Kudos to you for waking up at 6 a.m. For those who don't know, Allison is in Hawaii right now. So she woke up super early before 6 in order to make this meeting on time. Appreciate you doing this.
No problem.
Cool. Next up is Kristen, who's going to talk about nested column displays.